So in this video we're going to look at solving linear equations, and this is where we're really going to see pretty much every step we could possibly have in solving a linear equation. In this first video we're going to concentrate mainly on whole numbers. In the second video we'll concentrate on what to do when you have fractions. But I did want to go ahead and give you all of the 6 steps that you kind of want to look for as you're solving these problems. And the first thing we always want to do is we want to distribute all parentheses. I don't care if the problem has fractions, whole numbers, decimals, whatever it has, we want to distribute the parentheses before we start the problem. So the next thing we're going to do is, if we do happen to have a problem that has fractions, we're going to do this technique called clearing the fractions. It's a really great technique, and if you'll do 2 steps, you'll have a problem that only has whole numbers. Makes it so much easier to solve. So the first step is that you're going to multiply by the common denominator of every fraction in the problem. So we'll figure out what the common denominator is, and then we're going to divide out. And when we do the second step, if we've done the first step correctly and we've actually multiplied by the common denominator, you'll get all nice pretty whole numbers and you won't have to work with the fractions anymore as part of your problem. So it makes for a nice problem. The third step we're going to do is combine like terms. These like terms do need to be on the same side of the equation, so either both on the right or both on the left. Then we're going to add or subtract the variable to the same side, and it doesn't matter if we move it to the right or to the left, we're just going to move them all to the same side. Then our fifth step is we're going to add or subtract the constant, getting that away from our variable. And then finally, the very last thing we're going to do is actually divide by the coefficient and get our variable completely by itself. So these are the 5 steps that we're going to take, and we're going to ask ourselves these questions as we go through our steps, our problems, to make sure that we're doing the steps as they go. And this is by far not the only way to do it. This is just kind of gives you a nice guideline to go by. Okay, so the first problem that I have written here for you is we've got negative 9u minus 16 equals negative 7u minus 2. And again, we're going to ask ourselves those 6 questions. So first of all, do we have any parentheses we need to distribute? And as you can see, there's no parentheses in this problem, so we get to skip right over step 1. The second question would be, is there any fractions? And there's no fractions, these are whole numbers, so we can go ahead and skip over step 2. Next thing would be to look for like terms. So the easiest way to do this is for you to actually physically cover up part of the problem. So in this particular case, I'm going to cover up the right-hand side. The right-hand side. And I'm just going to look over here on the left and say, well, there's no like terms. It's a u and a 16. They're not the same. I can do the exact same thing, covering up the left, looking only at the right, and going, nope, I don't have any like terms on this side either. So I'm all the way down to step 4, and I haven't actually done anything yet. So on step 4, we start talking about moving our variables around. And we do have 2 variables. Notice we have a negative 9u on the left and a negative 7u on the right. So we need to move these 2 together. And it really honestly does not matter which one you move. If you feel more comfortable, we can always take this one on the right-hand side and move him over to the left, because that's typically what we like to see. We like to see our variable on the left-hand side. So if we do that, that means that we are going to take this negative 7 and move him over to this side. So this would be a positive 7u, doing the opposite of the operation. Since it's a minus, we're adding. So now we have negative 9u plus 7u, which would give us a negative 2u minus 16 equals negative 2. And be very, very careful, guys. One of the biggest mistakes I see people make when they're doing solving is dropping these negatives like this. So make sure that when you see that negative 2, that you actually bring it down as a negative 2. Okay, so now we've got all of our u's over here together, and now we need to move our constant. We have to move the negative 16 now. Again, the reason we have to move this is because we're wanting to move away from our variable, and if we move the negative 2, then we're moving towards our variable. So we want to move minus 16. The opposite of a negative 16 is a positive. So we're going to add 16 to both sides. So our 16s are going to cancel. We're going to have negative 2u equals 16 minus 2, and that's going to give us 14. a positive 14 at that, since I have more money left over. And then I'm going to do my last step, which is I need to get rid of this negative 2. I'm going to divide by that coefficient. So I'm going to divide both sides by negative 2. Again, my 2's are canceling in front of my u. So u equals, and then 14 divided by a negative 2 would be negative 7. And this would be my answer. So for our second example, we're going to solve the equation 8w minus 4 equals 4w. And what we're going to need to do is, again, move all of our w's to the same side. Because we don't have any parentheses, we don't have any like terms or anything like that, so we're right to our w's. Now, notice that I do have them on both sides of my equation. I can move this 4w over here to the left-hand side, and that would work just fine. However, if I want to try to make this problem, I guess, as quick as I can, I'd actually want to move the 8w over here on this side. And the reason why I would want to move the 8w to the right-hand side is because these w's are already all by themselves. There's nothing on that side with them. So it would by far be the easiest move to make. So if we did that, that means that we would subtract 8w from both sides. Remember, when you have a term that doesn't have a sign in front of it, this is automatically positive, so the opposite is a subtraction. Now, our 8w's are going to cancel each other out, and we're going to have negative 4 equals negative 4w. Again, making sure to look at where our variable is, where our w is, and since our w is over here on the right hand side, we're going to want to divide by his coefficient, which is a negative 4. We're going to divide both sides of our equation by negative 4. Over here on the left hand side, we have negative 4 divided by a negative 4, which gives us a positive 1. And over here, our negative 4's cancel each other out, leaving us w. So we get 1 equals w. And if you had chosen to move the 4 instead of the 8, you're still going to come out with 1 equals w. It had just taken one extra step. But you can do that either way. Okay, so for our next example, number 3 here, we're going to solve the equation 3 times 3x plus 2 equals 2x plus 27, and this is the first problem where we actually have a parentheses to it, so that's kind of great. So the first thing we need to do is take this 3 and distribute him to both the 3x and the 2. That's distributing those parentheses. We want to make sure we do that because then we can start talking about what we need to move or combine like terms, those kind of things. So here when we do our 3 times our 3x, that's going to give us 9x. And 3 times 2 is going to give us 6 equals 2x plus 27. Notice I didn't do anything to the right-hand side of my equation because there's nothing to do there yet. Okay, so the next thing I want to look at, since I have no fractions, is like terms. And again, remember, when we talk about combining like terms, we're talking about they're on the same side of the equation. So if I cover up the right and look only at the left, notice that I do not have any like terms. I just have a 9x and a 6. They're not alike. And if I cover up the opposite side again, notice that I don't have any like terms there either. So I don't have anything that I can actually combine together. So what I want to do next is start moving around my variables. So I want to move either the 9x or the 2x. And since it really doesn't matter, since we have both variables and constants on both sides of the equations, let's go ahead and do what we did in that very first problem, and let's take our 2x that's over here on the right and move him over here to the left hand side. Again, he's a positive 2x, so we're going to subtract 2x from both sides. So now we have 9 minus 2x. That's going to give us 7x plus 6. Our 2x's over here are going to cancel each other out, and we're going to have 27. So now we need to move our 6 because we've got all of our 7's together on the left-hand side. So we're going to move our constant out of the way, and we're going to subtract that 6 from both sides. So 7x equals 27 minus 6, which would be 21. And again, we're down to our very, very last step, and that's going to be that we're going to divide by 7. So we're going to divide both sides of our equation by our coefficient of x, which is 7. Our 7s are going to cancel, and x is going to equal 3. And there's our answer.